The moon is our planet's only natural satellite. It has been a constant companion to Earth for billions of years, influencing various aspects of our planet. It lights up our night sky and controls the tides, creating a rhythmic dance with the oceans that has shaped life on Earth. But the moon is slowly moving away from us, a phenomenon that has intrigued scientists for decades. Don't worry, this is a very slow process. The rate at which the moon drifts away is so gradual that it won't affect us in our lifetime. It won't affect us in our lifetime, nor will it impact the lives of many future generations. However, it's a fascinating phenomenon that tells us a lot about the history of our solar system and what the future holds. The moon's gradual departure is a clue to the dynamic nature of celestial bodies. The moon's movement away from Earth is a natural process, driven by the gravitational interactions between the Earth and the moon. It's been happening for billions of years, ever since the moon formed from the debris of a colossal impact. Scientists estimate that the moon is moving away from Earth at a rate of about 1.5 inches, or 3.8 centimeters per year. This steady drift is measured using precise, laser-ranging techniques. This may not seem like much, but over time it adds up. Over millions of years, this small annual drift will result in significant changes in the Earth-Moon system. The moon wasn't always this far away. In fact, it used to be much closer to our planet. Scientists believe that the moon was much closer to Earth billions of years ago, right after it formed. It likely formed after a Mars-sized object collided with Earth, a cataclysmic event in the early solar system. This colossal collision ejected a massive amount of debris into space, creating a ring of material around our planet. Over time, this debris eventually coalesced to form the moon, our constant celestial companion. Over the eons, the moon has been slowly moving away from Earth due to tidal interactions, a process that continues today. We can actually measure this increasing distance very precisely, thanks to modern technology. During the Apollo missions, astronauts placed special mirrors called retroreflectors on the moon's surface, a remarkable achievement. Scientists on Earth can bounce lasers off these mirrors and measure the time it takes for the light to return, a method known as lunar laser ranging. This technique gives us an incredibly accurate measurement of the moon's distance, allowing us to track its gradual drift away from Earth with great precision. The main reason the moon is moving away is because of the tides. The moon's gravity pulls on Earth's oceans, causing them to bulge out on the side closest to the moon and the side farthest from the moon. These bulges are what we experience as high tides. As the Earth rotates, these tidal bulges created by the moon's gravity actually pull the moon slightly forward in its orbit. This, in turn, transfers a tiny bit of Earth's rotational energy to the moon, causing it to spiral outwards. This process is a consequence of the law of conservation of angular momentum. The moon's gradual drift has subtle but important effects on Earth. Over millions of years, this slow but steady movement has been shaping our planet in ways we are only beginning to understand. One of the most noticeable effects is that Earth's rotation is slowing down. This deceleration is a direct consequence of the gravitational interactions between Earth and the moon. This means that our days are getting longer. While the change is imperceptible on a human timescale, over geological periods, it becomes significant. Don't worry, this change is happening very slowly, at a rate of about 1.7 milliseconds per century, so it will take millions of years for a noticeable difference in the length of our days. In addition to affecting the length of our days, the moon's recession also has implications for Earth's climate. The moon's gravitational pull influences ocean tides and, consequently, weather patterns. The moon's gravity helps to stabilize Earth's axial tilt, which is what gives us our seasons. Without this stabilizing force, Earth's tilt could vary more dramatically. As the moon moves farther away, this stabilizing effect will weaken. This could lead to more erratic and unpredictable seasonal changes. This could lead to more extreme climate variations over very long periods. The interplay between the moon and Earth is a delicate balance, and as it shifts, so too does the future of our planet's climate and environment.